The next video. In today's video I will show you how to do text recognition with MLKit and Tensorflow Lite inside your Flutter application using native code for Kotlin and Swift. So first of all, I have created a Flutter application, a default Flutter application. Next, what I have done inside main.dart, I have created this my homepage stateful widget, and I have referenced it over here. And for Android we explicitly need to ask for camera permission. That's why this code is only for Android, and here you can see that I'm first asking for Android camera permission, and this is the method which we have to write it on the native side as well. So be careful with this naming, as well as this is the method channel, and we have to use the same string on native side as well. And once we get the camera permission, then I'm setting this value as true, and if it is true, then I'm just showing the camera view. Otherwise I'm just showing a text of asking for camera permission. And for so here you can see, so this is false at the start only for Android, but for iOS it will be true. And once the user has granted the permission on Android, we are setting this variable as true as well. So here I have created another file called myCameraView.dart, and this is for the camera. So this is the camera view, and you have to use the same string on the native side as well. So here I have defined an Android view as well as a UIKit view. And once text has been recognized, we need a callback from native side to Dart side, to the Dart side as well, right? That's why I have created this callback of on platform created. And once we know that the view has been created, I am calling this set method called handler handle method. And here you can see this is how send from native would look like. So you will get some kind of a text whenever a text has been recognized from native side, and I'm just printing it as well as setting it to a variable, but you can use it however you want. So the next thing is, so for iOS, like for new versions of Flutter, you might have noticed that you won't see this pod file directly inside your iOS application, but I require this pod file because we need to add an dependency for text recognition MLKit externally. Now to create this pod file, all I did was I added this URL launcher dependency. Like you can add any kind of a dependency which creates a pod file for you. So I just use this URL launcher, but yeah, you can use any dependency you want. Like this dependency is not really necessary for this project, but I just needed this pod file to be created. That's why I think you can just do pod init as well, but yeah, I'm not sure. Like yeah, maybe you can try that. So if doing pod init works for you, then this you won't need this URL launcher thing. So here you can see in pod file I have added this dependency of Google MLKit text recognition. Once you do that, you have to run pod install as well from terminal. Next you have to go to app-delegate.swift, and here you can see that I am registering our camera view. So this is the same string which we have defined it on the Dart side. Next you have to create this camera view native view factory, and this is boilerplate code which we have seen many a times. And just important thing is we are referencing this camera view native view, so I have created that file as well. And here you can see we are first doing all this imports, and next we are extending AV capture video data output sample buffer delegate, and here we are creating our UI view first, then UI view for preview view as well as box view. Next, this is boilerplate code for doing embedding camera feed inside your application, and then I am doing an AV capture session. Then I have defined a channel, and here I have defined Latin option as well as Latin text recognizer. And but the text recognition library also supports Chinese, Devanagari and Arabic. So if you are curious for that, you can check out the documentation. It is more or less the same as Latin. And here I am creating our UI view object, and once I get a Flutter method channel of camera view, I am creating the native view. I am initializing the channel as well as I am creating a native view, and here I am just returning our parent view. And in create native view I am initializing our Latin options as well as Latin text recognizer. initializing preview view as well as adding it as a sub view, and similarly for box view as well. Then we are setting up AV capture. Now this code is the same, like this is boilerplate code for starting any kind of AV capture session. So this thing remains the same. Now important thing is over here, so every frame that has been captured from your camera, it will so the camera will give you an image buffer, and that image buffer needs to be converted to a UI image. So for that I have written an extension for this. Once it is converted to a UI image, we convert that to a vision image and then send that vision image to our Latin text recognizer. And once that is done, we are extracting all kind of text from that particular frame. I'm printing it to the console as well as I'm sending it to the native side as well. So here you can see I'm sending everything back to the native side. As well as you can use this code to stop the camera as well whenever you want to. So here you can write stop camera here or here something, so whenever a particular text has been recognized. Also in info.plist you have to add this camera permission. So I think, yeah, that's it for iOS. So for Android, first go to app, src, main, android manifest.xml, and you have to add this camera permission, as well as you have to add this metadata as well, because we sorry, not this, this one, sorry. You have to add this metadata as well, because we will be using downloading the TensorFlow Lite from Google Play services. We don't want to embed it inside your APK, as it might increase our APK size. Next, inside build.gradle, you have to add this dependency for text recognition, as well as I have added all the dependency for camera X as well. And next I have set the mean SDK version to 23. Next, go to Kotlin, go to main activity.kt, and here you can see I am first asking for the camera permission, and I am requesting the camera permission, and if all permissions has been granted, we are sending a callback of true to the Dart side. And here you can see we are registering our camera view, as well as we are registering our method channel for getting the camera permission as well. Next, for the camera view factory, so this is like boilerplate code which we have seen many a times, and here we are referencing our camera view. And inside my camera view.kt, here you can see that we are first initializing our camera X. So this is like boilerplate code for initializing our camera X, as well as this camera and image analysis for every frame that has been captured. Then we have a text recognizer as well, and here we are initializing layout params, as well as setting our layout params to preview view, then setting up our camera. And again, this is boilerplate code for starting camera as well as creating camera executor. And now this process image proxy method gets called for every frame that has been captured. And here you can see I have a media image from image proxy, which we are converting into an input image and then sending it back to our recognizer. And once it has successfully recognized, I am printing it to the console, all the stuff, as well as I am sending it back to the native side as well. So here you can see, and this is for failure listener as well as for complete listener. And if you want to stop capturing, then you can just call this code over here somewhere here, whenever a particular text has been recognized, or you can just uncomment this out. Then here we are just returning our preview view, and for dispose I am shutting down the camera executor, and this is boilerplate code for starting the camera. So yeah, I think that should be it. Thank you for watching. Bye.